Chowdhury, an upcoming sophomore at Monte Vista High School, and today I want to talk about the double derivative and its applications. So why don't we start off with its applications? Now, all of you people who do physics, you guys know and you guys deal with velocity, acceleration, distance, but how do derivatives have any part to play in that? Well, why don't I explain that to you right now? So let's say we're given this physics problem. A particle is moving along a plane, and the distance is given by s, which is distance, is equal to 6t squared minus 7t, where t is equal to time. Okay, so let's rewrite that problem. S is equal to 6t squared minus 7t. Now remember, taking the derivative is just finding the rate of change. So let's say we take the derivative of s, right? ds dt. And if you take the derivative, it would equal to 12t minus 7. Now, ds dt stands for change in distance over change in time, which, as we know in physics, is velocity. So, that's how derivatives play a part. But that's only its first derivative. This portion over here is only the first derivative. So how are we actually going to take the second derivative? I'll go over right now and I'll explain to you what will happen if we take the second derivative. So let's start off with a problem over here, and then we'll go back over here to the scenario so you guys can finally get the answer to this problem, which I'm leaving as a cliffhanger right now. So let's start off with this. Problem number 1. Where y is equal to 4x cubed plus 2x squared plus 3x plus 9. Let me erase the first problem now, because kind of get a grasp of it, and I can rewrite this one over here. Y is equal to sine x plus x cubed. So we can get some more space to do our problem. So taking the first derivative, no problem. We already know how to do that. Dy dx will equal to, now if you're to use the power rule on all of these, you bring 3 down, multiply by 4, 12x, subtract 1 from the exponent, so it's 2, plus 4x plus 3, and taking the derivative of the constant would equal 0. So that's your first derivative, no problem. But now what do we do for a second derivative? Funny story, you do the exact same thing, except you do it with this. So when we do the second derivative, we denote it as d2y dx2. Or if you guys use your dashing system, it would actually be f dash dash of x. But that's only if you do dashers. But I would recommend writing it this way because it's much more clear to the teacher. So d2y by dx2, and you're going to use the power rule. You can use all the rules you guys know for like the first derivative, power rule, chain rule, just about anything, and you could apply it to this. So power rule here, 24x power of 1 plus 4, and this is your second derivative. So let's do the second problem and I'll get back to this. So again, taking the second derivative is pretty much the same thing as taking the first derivative, except you're taking the derivative of the result you got in the first derivative. So now we have problem 2 over here. Problem 2 is y is equal to sine of x plus x squared. I added some trigonometry into this problem so it could be a little bit more difficult. So let's see how this one goes. So we're going to do the same thing. We're going to do dy dx. And remember, this is just our first derivative. And it's equal to the derivative of sine x is cos x. These are just our trig values that we know from derivatives. So plus power rule of that is plus 2x. And so what we're going to do is we're going to take the second derivative now. No problem. d2y dx, and it's going to equal to negative sign, the derivative of cos x is negative sign x plus 2, just using power rule or product rule. And yeah, that's our second derivative. No problem here. So now back to the question that a lot of you guys may be asking. How does the second derivative help us in terms of physics? Now, I would like you guys to think about it first yourself before I go over it. And so why don't we just jump on into it? So, we were just given velocity. Okay, so velocity is our first derivative. So, if we were to try taking our second derivative, we would be taking the derivative of velocity. So, let's go over what would happen if we take it. So, we can write velocity as v, and our v is equal to 12t minus 7. So, taking the derivative of this, you would take it in terms of t, so dv dt is equal to 12. And again, this, what it's saying is it's the change in velocity over change in time. And as we know from physics, change in velocity over change in time is none other than acceleration. And so that's actually what the second derivative does for us in physics. Now, even though it doesn't seem like the second derivative because we didn't write d2v by d2 dt2, it's actually the second derivative of the distance. Because you're taking the derivative first, it's going to give you velocity. So you're actually going to take d2s by d2 dt2. And so that's actually the double derivative and its applications. I hope you guys liked the video, and thank you guys for watching.